So we're looking at dimensional analysis, and we're going to start with this problem. So if you're watching this later, you'll know what the heck we're talking about. If we have a drippy faucet, so here's a faucet. Doesn't really look like a faucet, but hang on. There we go. Okay. And it's dripping, and we put a graduated cylinder underneath it, like this, and we time it. We'll find that over time it starts to fill up with water. Okay, so we actually did this experiment, and we got that you get 24 mils of water in there every 15 seconds. Okay, so how I would start, and then the question is, how much water would we get after 1 hour, 1 day, and 1 year? This is our starting point. And we'll maybe designate that these values should be in terms of liters. Okay, we'll say they should be in terms of liters. So there's multiple ways we can deal with that. We can deal with changing to liters after, which I think is the way we're going to go. All right. So 24 mils in 15 seconds. Having a 15 seconds on the bottom isn't really useful. We don't really tell time in terms of blocks of 15 seconds. Well, I guess we technically could, because there's four of them per minute. So there's one way or the other that we could go. Okay, so we could go with 24 divided by 15, which will give you 1.6. So if we actually do the math on that, we get this. So if we actually do this division, you'll get 1.6 milliliters happening every second. So this is saying 1.6 milliliters happens every second. Or if you want to do it in terms of minutes, you can multiply that by 4, right? And that'll get us up to a minute. So you could say it's the same as saying there is 48, that's not right, 96 mils per minute. Okay, I think that's right. I started with this, so that's what we're going to use. Okay, now if we want to know, we want to go from mils per second to mils per minute. What are we going to have to do to this value? I'm going to have to multiply it by 60, right? The reason why is because we have a conversion factor that says there are 60 seconds per every 1 minute. Okay? So I'm going to go ahead and do that. Times 60, and I'm going to bring my units along. Okay? The key to making sure dimensional analysis is working for you is to actually do the math with your units that you're doing with your magnitudes or your values. So we're going to use the conversion factor that there's 60 seconds per minute. And if we actually get our calculator out and do a quick multiplication, that's where we get our 96 that we found before. So the thing about dimensional analysis is we're not going to ignore our units. We're going to bring them along. So the units are going to come through in the multiplication. So mils per second, that's what we already had, times seconds, times minutes. So if we have a second, a per second multiplied by a second, it's the same as saying 1 over s times s just equals 1. Okay, like we would normally do in any kind of algebra that we were dealing with. And so what that means then is that these guys, these seconds here, are just going to cross off. And we'll end up in, and this was a per minute, we'll end up with the unit 96 mils per minute, exactly like we expected. Okay, so what we've done is we've analyzed this, and we've converted 1.6 milliliters per second to the equivalent of what would happen if we let it go for a whole minute. Does that make sense to everyone? And how we kind of like have a check and balance on this is we make sure that our units actually mathematically work out to be the unit that we're interested in. I mean, I know with something like this, you just kind of know that you multiply by 60, but we're going through the process because in some cases it might not be quite so obvious. Like for instance, if we were converting from imperial measurements to metric measurements, or using like sort of exotic units like light years, for instance. How many kilometers are in a light year? Well, there's a way to figure that out based on our input values. But we'll start simple. Okay, so now we need to know hours, right? So we're going to take that unit that we just sort of pulled out of here, and we're going to start with it. And we're going to say, well, if there's 60 seconds per minute, there's also 60 minutes in every hour. Okay? So we're going to multiply again by 60. And we'll get, beat me to it, 5760 mil. And we've got mils, minutes. Sorry, this is a per minute times minute, and then per hour. So the per minute and the minute would cross each other off, and we'd end up with the units per hour. Okay? So ensuring that we're watching what our units are doing as we multiply through, we can ensure that we're always in the right, we're always getting the right answer, the answer that we're looking for. Okay, so this is like a way to confirm that it is actually 5,760 mils. Now we also said we might want to actually get these answers in terms of liters, right? We'd rather have it in terms of liters. So we know from experience that there's 1,000 liters in, oh, no, that's not right. 1,000 milliliters in every liter. Let me just make sure I'm saying it right. So there's 1,000 milliliters in every liter. Okay? So what we want to do here is we want to take our value of milliliters, and essentially we want to divide it out by 1,000. But if I look here, okay, I can't just do this. This would be incorrect, right? Because I have milliliters here, and I have milliliters here, and I'd actually end up in terms of milliliters squared. Do you see what I'm saying? So the question is, if we want to just kind of keep doing what we're doing and using multiplication, how are we going to deal with that? So the way to do that is to invert this value, and that will invert our units. So watch what I'm going to do. I'm going to say 5760 mils. I'm just going to leave off the hours here for a sec, just so don't worry about that right now. Times 1 over 1,000. So I'm inverting, but I'm also going to invert all of this. So what's the inverse of milliliters? Mil to the negative 1. And what's the inverse of per liter? Just liters. Aha. So now what we're doing is exactly what we would expect. Multiplying by 1 over 1,000 is the same as dividing by 1,000. And that's what we have to do, right? If we have a value in milliliters, divide that value by 1,000, and we drop down to liters. So the check here, the dimensional analysis check here, is will milliliters cancel off if we do this? And yes, it will, like that. And we should end up with 5.76 liters, okay? Because that's the last remaining unit once these have been crossed off. And of course, that's per hour, because that's what we're looking at. So I'm going to pause there for a second and let you think about that. Okay, so hopefully, so far, so good. What we're saying here is this unit is the equivalent to this unit. Oh, yeah. Maybe that's not the best way to do that. I'll do it this way. Okay, so 24 milliliters dripping out of a tap every 15 seconds is the same thing as saying we're going to have 5.76 liters coming out of there per hour. It's the same thing. It means the same idea. Okay, you probably dealt with velocities last year, where you could talk about a velocity in terms of kilometers per hour or meters per second. They mean the same thing, but the values will be different. Okay, so we'll continue this on. It's not really too much more to do, but if you have 5.76 liters coming out every hour, how many do you have per day? Well, you have 24 hours every day. So 24 hours we want to get rid of. It's a negative, so it's got to be positive over here. Okay, so 5.76 times 24. You're going to get 138.24. Yeah, so we cross, and no, we don't have to inverse because we want to know liters per day, right? Here's my per day. I already had per hour. there's 24 hours per day. So the -1 is here. The -1 here crosses out with that. And we're in terms of liters per day. Okay, and last but not least, we want to take this value in liters per day and see what this equivalent unit is in terms of liters per year. So let's deal with years now. And so we've got 138.24 liters coming out every day. And we know that there are 365 days every year. Okay, cancel, cancel. Do the multiplication, and we're left in liters per year, and that should be. So I think this works out, like if this is how many liters per day times 365, you get something like liters per year. Okay, here's a classic problem, a dimensional analysis problem that happens for Canadians when they go to the US, or probably US people when they come to Canada. Gas prices. So we've got two problems when we're looking at gas prices. So we'll start out with some information. So today, where we live, gas prices are, this many dollars per liter. Okay, $0.889 per liter. And where we're looking in the US, which is in Minneapolis, and we're in Winnipeg, by the way, $2.03, and that's US dollars. This is Canadian dollars. This is US dollars. Dollars per gallon. Okay? So how do we figure out where gas is cheaper? Okay? We have to do a double conversion. We have to first figure out what this is in terms of Canadian dollars, and then we have to figure out, when we're dealing with gallons, how many liters that is. Okay? So here's some factors that we need to consider. The first is that 1 gallon is equal to 3.785 liters. Kind of round it there. And $1 Canadian will only buy you 76.76 or 76 cents US. Here, maybe we'll just call this CAN. Make more sense. All right. So let's bring, because we're Canadian, let's bring the US value into our domain. Okay, let's find out what this actually works out to in Canadian dollars per liter. Okay, so we'll start with that, and let's work on the US dollars first. US per gallon. So what we've got here is we've got 0.76 US for every can, right? And we want to get rid of the US and we want to convert it to Canadian, right? So we're going to have to use that little inversion trick we used before. We're going to say times 1 over 0.76 per US for every Canadian. Okay, so we inverted it. Does that make sense? Should our value be higher or lower when we convert it to Canadian dollars? It should be higher. So if I divide by 0.76, I will get a higher value. Okay, so that's the second mental check to kind of like figure out if I'm sort of on the right track here, right? Should I end up with a higher or a lower number? So if I multiply through, okay, US per US, I end up with Canadian, and per gallon is exactly what I want. So let's do the division. So this will give me, why did it change color? I have no idea. $2.67 Canadian for every gallon. Okay? 267. Now what we have to do is we have to use our other thing, this conversion, and we have to work it out. So right now we have that there is 3.785 gallons, no, my bad, liters in every gallon. Yeah, sometimes I rush and I say it wrong. liters in every gallon. There we go. Now, if I do my multiplication, they're not going to jive, right? So I had to do my inverting again. So, and the way to think about it is a gallon is bigger than a liter, so I should end up with more gallons than I had liters. I should end up with a higher value. Or maybe I said that backwards. But the point is that we're going to invert this. I'm going to divide by that. We get per liter. We get gallons. Gallons will cross off. And this should be our final value. 2.67 divided by 3.78. And I get 0.706 Canadian per liter in Minneapolis. So is it cheaper? Yep, it is, because here it's, remember, 0.889. It's not crazy cheaper, but it's definitely cheaper. And that's probably mainly chalked up to tax, differences in taxes, I would think. It's cheaper in the US, okay? This was, because remember, this is what we're doing. We're taking the 203 US per gallon, and we're converting that US currency to Canadian currency, so that's 267 Canadian per gallon. And then every gallon is 3.785 liters. So we're going to take our value in gallons and divide it out into 3.785. And we end up with 0.706 Canadian per liter as the price in the US. In Minneapolis and in Winnipeg, it works out to 0.889 Canadian per liter. So a little bit cheaper in the States, about 10 cents a liter. No, 18 cents a liter, 19 cents a liter. And that will wrap up this video.